I've gotten a couple questions on how to calculate the theoretical yield for the What's My Formula lab. I know we went over this in lab, and then I also talked about how to calculate theoretical yield in the video on chapter 9 that I uploaded to Canvas. But I'm going to go through one example on calculating theoretical yield for the lab specifically. But I expect you all to do the rest parts B, C, and D on your own. But I just want to make it clear what is expected from this lab. On page 36 of your lab manual, you should have unknown number, the mass of the evaporating dish, and unknown, the mass of the evaporating dish itself, the mass of your unknown, the mass of the evaporating dish and product first heating and second heating, and the mass of your product experimental already filled out, because you get all of that information from doing the lab experiment itself. The last three rows of the table on page 36, the mass product theoretical, the percent yield, and the identification of the unknown, you can only figure out after you calculate the theoretical yield for parts A, B, and C on pages 37 and 38. So that's where I am going to give you an example on how to calculate those theoretical yields, and then you can use that information to complete page 36. So calculating theoretical yield, you need to do it for each possible salt product, of which there are 4. I'm just going to show you sodium carbonate. It's part A. The question's asking, what is the theoretical yield of the salt product? I want to know how many grams of sodium carbonate solid do I get if heating my starting material, my reactants, goes to completion. So I want to know the grams of the solid product. And the only thing I know to start with about how much of my starting material is the mass of my unknown. I don't know what my unknown is, but for each of these calculations, I'm going to assume it's whatever the starting salt is. So for part A, the starting salt is sodium hydrogen carbonate. So in my experiment, the mass of my unknown salt, once I weighed it, was 3.15 grams. And I'm assuming it's this. So I'm pretending my unknown is sodium hydrogen carbonate. If I want to figure out if 100% of my 3.15 grams of sodium hydrogen carbonate got converted into products, how many grams of the product should I get in that scenario? I need to do conversions using the balanced chemical equation. Grams of sodium hydrogen carbonate, I cannot put that into the balanced chemical equation because the balanced chemical equation only accepts moles. Everything is read in moles. All the coefficients are moles. So I have to convert my grams into moles, and to do that I need to know the molar mass of sodium hydrogen carbonate, which your lab manual asks you to calculate. The molar mass is the conversion factor that relates grams. So I get 84.007 grams for every mole of sodium hydrogen carbonate. Write out your units, please. You will get marked off for not having units written out, but you will also get very confused in long calculations. So I'm going from grams of sodium bicarbonate. If I put grams on the bottom for my conversion factor, they will cancel. I'm left with moles of sodium bicarbonate. Now I can put this into my chemical equation. I can use the conversion factor, the stoichiometric conversion factor from my balanced chemical equation to get from moles of sodium hydrogen carbonate. So I want that on the bottom, and so that they will cancel, and I want to be left with moles of sodium carbonate, my product. I need to look at the balanced chemical equation. 2 moles of sodium hydrogen carbonate, when it decomposes under heat, will give me 1 mole. The 1 is not written, but it's there. 1 mole of sodium carbonate. Now I will be left with moles. And I can keep track. Grams of sodium hydrogen carbonate cancel. Now the moles cancel of sodium hydrogen carbonate. And now I need to get from moles of sodium carbonate to grams of sodium carbonate. And to do that, I have to go back to the molar mass, but now it's the molar mass of sodium carbonate, which your lab manual also asked you to calculate for each salt type, parts A, B, C, and D. In this case, for every 1 mole of sodium carbonate, Na2CO3, it's 105.989 grams of sodium carbonate. Now I can put all this information into the calculator, crunch the numbers, round to the correct significant figures, and I will get the final answer for the theoretical mass of the salt product for part A. You're going to go through and do that for parts B, C, and D using the subsequent chemical formulas and salt products. Once you're done calculating all of the things, you are then going to compare your product mass experimental to each of the 4 theoretical yields you calculated. Whichever theoretical yield is closest to your experimental mass is what you write in the mass product theoretical row on page 36. So if I finish this calculation, and let's say 3. Okay. So whichever of these your experimental yield is closest to, the things you calculated, that's what you write in the mass product theoretical row on page 36. For the percent yield row, you're going to take your experimental in grams divided by your theoretical in grams times 100. Tells you how efficient the reaction was. I don't know if it asks this in your lab, but I want you guys to brainstorm reasons why experimental might not be more or less mass than theoretical. The last row, the identification of the unknown on page 36. You write the name of your salt product. You write the name of your, salt starting material, salt reactant. So if I found that my experimental mass is closest to the theoretical yield in part B, then my identification of my unknown would be sodium hydrogen carbonate. But it's going to depend on what your experimental mass was closest to. Part 4 is just identifying the unknown, is just writing the name of the salt reactant based on whatever your experimental yield is closest to for the theoretical yield.